Okay, so when we compare DRAM with SRAM, we notice a few things. DRAM needs constant refreshing. This makes it slower than SRAM. SRAM doesn't need refreshing, but it's more expensive. Main memory, DRAM, is physically housed on DIMMs and SIMMs, which we'll talk about in just a minute. Cache memory is physically housed on the system board in either a COAST module, cache on a stick, or in a single chip that's included inside the processor case. The technologies for main memory RAM or DRAM are fast page mode, FPM, EDO, which stands for extra data output, and then there are synchronous technologies like synchronous DRAM, direct rhombus DRAM. There are many different technologies, and we'll talk about some of these technologies as well. Technologies for cache RAM include synchronous SRAM, burst SRAM, pipeline burst SRAM, asynchronous SRAM, and new types of RAM that are housed within the processor case. So depending on what type of memory that we need, we'll choose either a SIM or a DIMM. A SIM is a single inline memory module. It has a data path of 32 bits and can come in varieties such as FPM, fast page mode, or EDO, extended data output. DIMM technologies, DIMM stands for dual inline memory module, and it has a 64-bit path. In other words, it's like a 64-lane highway for data versus a 32-lane highway. And it uses a burst EDO or a synchronous dynamic RAM technology. So technologies are in great amount determined by the system board that we choose. Let's overview some of the latest memory technologies for the latest boards. Some of the latest technologies include RDRAM, SDRAM, and DDR SDRAM. These are some of the fastest memory technologies that are available today. Other terms that you might see are error checking and correction, ECC. This is a chipset feature on a system board that checks the integrity of the data stored on a DIMM, and it can correct single-bit errors in a byte of data. A byte of data contains 8 bits, and parity memory is another way supported by some older system boards in which a 9th bit was added and it was used for error checking. Then we also have non-parity memory. Most memory that we buy is either going to be ECC or non-parity memory. It's slightly less expensive and it doesn't have error checking. So next, we'll take a look at how the operating systems view memory.